Alright guys, here's my beginning to my Lab6 code. As you see here, we have the serial monitor printing, we have potentiometer, we have the servo. So if I turn the the potentiometer, see, it causes the servo to rotate. Turn it the other way, and it changes to 0, and then yeah. Alright guys, for the next part of the lab, it's the digital to analog conversion. So first of all, the least significant bit voltage based on that would be 0.625 volts. I did a couple of just hand calculations for different settings. So you can see we'd be looking at 2.5 volts for the first one, 3.125 volts for the second, and then 3.75. So let's come over here to Circuit Lab. We simulate the first one, hit run DC solver. Right there, we're getting that 2.5 volts. We come back to build. We change it to now having this switch not at ground. We go back to simulate and run. There we go, got 3.125 volts. We go back to build. We turn this switch back to being off, and then we turn this on. We come back to simulate, run. That's where you get the 3.75 volts. Alright, so now when it comes to implementing the R2R DAC, we see that we currently have all of them in power, which is a voltage output of 4.375. If we refer back to the scenarios I had before of where the least significant was in ground, we see the voltage jumps down to 3.75, which is just as what I had before. If we now power that one, turn the second bit to ground, we get 3.13, which I was getting 3.125 on Circuit Lab. And then finally, if we do just the most significant bit as high, we get, oh, I'm sorry, I gotta switch that. Then we get 2.5 volts, which is just as what I had found before. And then when it comes to adjusting the servo, you can see, so if I put all of them to ground, we're here, and then if I move them all starting with the least significant bit to power, you can see it rotate. And then this is, again, I just did this with a bunch of 1 kilo ohm resistors, putting them in series to make up 2 kilo ohm resistors.